Hello. Now the next topic is alternating series. First, the definition of alternating series. A series in which the terms are alternatively positive and negative is called an alternating series. Look at this. The series sigma n equal to 1 to infinity minus 1 the whole raised to n plus 1 an is equal to, first term is positive a1 minus a2 plus a3 minus a4 plus etc. This is an alternating series. Okay, the terms alternatively positive and negative is called an alternating series. Now Leibniz test for alternating series. A series sigma n equal to 1 to infinity minus 1 the whole raised to n plus 1 an converges, that is the alternating series converges if and only if the two conditions are satisfied. An, first condition is an greater than an plus 1 for all n, and second condition is limit n tends to infinity an is equal to 0. If these two conditions satisfied, then the alternating series is said to be convergent. Okay. Now the first question, examine the convergence of the series 2 minus 3 by 2 plus 4 by 3 minus 5 by 4 plus etc. Clearly this is an alternating series because the terms are positive and alternatively positive and negative. So clearly it is an alternating series. So we are using Leibniz test for the convergence or divergence. Okay. First of all, the series clearly it is an alternating series. It is an alternating series. Now what is the un of this series? Here what is un? Un is equal to n plus 1 divided by n, isn't it? First term is 2, the numerator of first term is 2, second term is 3, third term is 4, and fourth term is 5. Therefore the nth term, numerator of nth term becomes n plus 1, and look at this denominator 1, 2, 3, 4 etc. So the nth term denominator is n. So n plus 1 by n is the un here. Okay. Now we are writing un plus 1. Un plus 1 is equal to n plus 2 divided by n plus 1. Now we have to show that un is greater than un plus 1. That is the first condition in Leibniz test. Okay. So I am dividing un plus 1 by un. Un plus 1 divided by un is equal to n plus 2 divided by n plus 1 into n by n plus 1. Okay, this is equal to n into n plus 2 divided by n plus 1 the whole square. Okay, so here the denominator is the bigger one. Okay, n into n plus 2, that is n square plus 2n. Here n square plus 2n plus 1. So denominator is a bigger one. So we get this is less than 1. Okay, denominator is greater than the denominator. So we get the ratio which is less than 1. So un plus 1 by un less than 1 means that un is greater than un plus 1. Therefore un is greater than un plus 1. So the first condition satisfied. First condition of Leibniz test is satisfied. Now what is the second condition? Second condition is limit n tends to infinity un. We have to show that limit n tends to infinity un is equal to 0. Okay, we have to check whether this becomes limit n tends to infinity un becomes 0. So what is un? Un is n plus 1 by n. N plus limit n tends to infinity. Limit n tends to infinity n plus 1 divided by n. So this is equal to limit n tends to infinity 1 plus 1 by n. Dividing both the terms in the numerator by n, we get 1 plus 1 by n, and this is equal to, what is the value? This is equal to 1, which is not equal to 0. Applying n equal to infinity, here we get 0, and we get the value as 1, and 1 is not equal to 0. So the second condition did not satisfy. Therefore the second condition of the Leibniz test, second condition did not satisfied. Therefore the given series is divergent. Okay, the given series does not converge. Therefore the series is divergent. The series is divergent. Okay. Now one more problem. Examine the convergence of the series 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. This is also an alternating series. So what is the un here? Un is equal to First term is 1, second term 1 by 2, third term 1 by 3, fourth term 1 by 4, and the nth term is 1 by n. Okay, and what is un plus 1? Un plus 1 is equal to 1 by n plus 1. Now what is un plus 1 by un? Un plus 1 by un is equal to 1 by n plus 1 into n. Okay, and this is equal to n by n plus 1, and clearly this is less than 1 since numerator is small and denominator is big. So this is less than 1, and therefore un is always greater than un plus 1. Okay, therefore the first condition of Leibniz test satisfied. Now limit n tends to infinity un. Now we have to find out limit n tends to infinity un. Limit n tends to infinity un is equal to limit n tends to infinity 1 by n, and this is equal to 1 by infinity, and which is equal to 0. So we get limit n tends to infinity un is equal to 0. So both the conditions of Leibniz test are satisfied. Both the conditions of Leibniz test are satisfied. Therefore the given alternating series is convergent. Therefore the series is convergent. Okay, thank you.